100B Unit 3 practice test, 18 questions. And I've started this a couple times and I've been having some problems with my computer. So I'm going to just go through where I left off last time and hopefully save a little time. So here we go. Which two rays form angle ACB? So it's going from A to C to B. So a ray has a definitely starting point, and both the rays are going to start at C. So CB is a ray, and AC is a ray. So those are my two rays, CB and CA. And then number two, let's go down a little bit if this will let me. My computer's been real finicky this morning. At some point it will let me. But it's asking what type of angle. There we go. What type of angle is ACB? And ACB, well, it looks to me to be greater than 90 degrees, so I'm going to call it an obtuse angle. And I can look at ACD, and that looks acute. And if that's acute, that means the other one has to be obtuse, because they share the same, their exterior side is a straight line. So that means they're supplementary angles. But so I'm going to say obtuse. And let's go down to number 3. And whoops, I went a little too high. And as you can see, we're talking, let me get my pen back, even though I've already written on this. I don't need my highlighter, I need my pen. Okay, let's see what's happening here. Well. What type of angles are 5 and 8? 5 and 8 are opposite angles, and we call those vertical angles. And they're always the same. Opposite angles are always the same value. So vertical, what's the measure of angle 7? Well, 7 is going to be the same as 6 because they're opposite or vertical angles. And 7 is going to be the same as 3 because it's corresponding. And then we know 3 is the same as 2. So from that, we know it's going to be 120. And they're also, 7 and 2 are also exterior alternative angles. So they're the same. Just like 8 and 1 is the same. And interior alternate angles are the same. Just like 5 is the same as 4 and 6 is the same as 3. Alright, more information than you needed, but it doesn't cost anything. Now we're getting up to number 5. What is the measure of the interior angle of a regular octagon? So an octagon is 8-sided. Yeah, now I got my pen working. So n, the number of sides, is going to be 8, and we have this formula here that says n minus 2 times 180 will equal the sum of the interior angles. Interior angles. So n minus 2 times 180, so n is 8 minus 2 times 180, that's 6 times 180, and I get 1080. But they want to know just one interior angle. So now I have to divide that by 8, and this tells me that each angle is 135. Boom. And just remember that the term regular in geometry means they're all the same. And so now we move to this really big figure, a 26 gon. So n's going to be 26. Of course, my pen stops working again. Computer takes another break. N equals 26, so 26 minus 2, because we use the same formula, n minus 2 times 180. 26 minus 2 times 180, so 24 times 180. 24 times, so somehow I get 4,320. That's when I do 24 times 180. All right, and we're up to number 7. Whoops, Whoops, I don't have to hit that. I just have to get this to go up just a little bit higher. Let's see, I'm not seeing my cursor anywhere. Believe it or not, I'm hitting the button, and it's not doing anything. There we go. I can see my cursor now. That's positive. And then I went too far. So now I got to go all the way back up. There we go. Number 7. And they're talking about AC. I got to get my pen back. AC. AC is the diameter. There it is. And we know that angle BDC is 140. And we also know that because this is a central angle. It starts at the center of the circle. And so it's always the same as the arc length. So we know that's 140, and I know from C to A is a half circle, so that's 180, or this is 180 degrees. And so we know that what's the measure of arc AB? Well, if the whole thing's 180 and this is 140, this has got to be 40, because 40 plus 140 is 180. And we're going on to number 8. Maybe. Boy, this has been so finicky today. There it is, number 8. Which of the following is the radius of circle D? So we've got a few radiuses. I see DC is a radius, DB is a radius, and AD is a radius. So there's 3 radiuses, but BD is the only one that's given. AB isn't. There's no line drawn there. It would be a chord. BC is an arc because it's curved, and AC is the diameter. So the only proper answer choice is BD. Hopefully you got that right. And let's see, please. This is going to jump way up there. There. I guess it didn't jump that far. So I drew a little right triangle because it said in a right triangle. And the measure of one acute angle is 13. So I said this is my 90. And so I made this one right here 13. And so I have 90 plus 13, and that's where I came up with this 103. And I know all 3 angles equal 180. So 180 minus 103 gives me 77. So this angle had to be 77. And we're on to number 10. In an isosceles triangle. So isosceles triangle, 2 sides are the same, or 2 angles are the same, and one's different. One angle measures 10. So it could be 10, 10, 160. That's 180. 10, 10, 160. Or it could be 10, 85, 85. Because I got 2 angles are the same, and all 3 add up to 180. So both of those would work, because 85 plus 85 plus 10 is 180. So, and the way I figured that out was I knew 10 plus 170 was 180, and then I just divided 170 by 2 and got 85. So those are my 2 types of isosceles triangles when one angle is 10. So what are the measures of the other 2 angles? Select all that apply. Well, there's 10 and 160, and there's the 85, 85 from our 10, 85, 85. And now we're on to number 11. We're starting our last 8 questions of the day. And come on back. Boy, my computer wants to get done. It's already up to 14. See if it'll go back to 11. There we go. Stop. Stop. Okay, what is the measure of angle 1 in the rhombus? Rhombus, I know all angles add up to 360. I also know that opposite angles are the same. And I know that these 2 angles, this 40 and this 1, are going to add up to 180. So 40 plus what is 180? 40 plus 140. And if this is 40 and this is 40, and these 2 are the same angle, well, let me get my pen working. these two angles are going to be, it's supposed to be working. There it is. These two angles are supposed to be the same. Then I have 80 plus something equals 360. So that something is going to be what? 280. And then half of 280, because there's two angles there, is 140. So 40 plus 40 plus 140 plus 140 is 360. We did it. But the easiest way to know is just that 40 plus angle 1 is going to be 180. So now let's go to a trapezoid question. If I can find my, there we go. Check that out. All right, question 12. This is where my computer stopped last time I was doing this. All right, and please write. Oh, there we go. With a trapezoid, I know this is parallel to this. Those two lines are parallel. That's a trapezoid, two parallels. And I don't know any relation between the opposite angles, but I know that this angle, my computer's taking another break, this angle and this angle are supplementary. So they add up to 180. So 105 plus angle 1 equal 180. And 105 plus 75 is 180. Is that a choice? Yeah. And so this angle has to be 130. But they don't ask us to figure that one out. They just wanted us to figure out angle 1, and we did. We're already to 13. What is the perimeter of the larger of two similar polygons? That means they're proportional, like models. Okay, so if this is, I'm going to put the side over the bottom over here. So 2 is to 4 as x is to 6. Because see, the same here, this and this. Those are, so we have them in the same order. And now I just have to figure out what does 6 have to be. And to solve for these, whenever I set up a proportion, I can just take cross products, and the one with the 2 divided by the one with 1 will always equal x. So I get 12 over 4 equals x, and 12 over 4 is 3, so x equals 3. And that's true because 2 over 4 equals 3 over 6, because all of those equal 1/2. So, but that's not what they asked. Got to read the whole question. They want to know the perimeter. The perimeter is the distance around the outside. So if this is 6, this is 6, and if that's 3, this is 3. So 3 and 3 is 6, and 6 is 12, and 6 is 18. So the perimeter is 18, and I've got 4. Nope, we got 5 to go. We got to do 14, 15, 16, 17, and 18. But first, let's do 14, while my computer goes on to 15. All right, come on, 14. There you are. Given A, B, C, D is similar to E, F, G, what is the measure of angle H? So first, this is a tricky one because we got to set them up so they're facing this, that they look the same. But my pen stopped working again. Now it should be back. So I'm going to redraw. So, you probably don't like my drawing. E, F, H, G. Okay, so now I kind of drew these so they're the same. So A is the same as E, B is the same as F, D, not the same, but proportional to H, and C is proportional to G. And even though the sizes may change, similar shapes have the same angles. So h is going to be 100. I can't draw it. Just trust me. It's going to be 100. Because like this little triangle, let's say that's an equilateral triangle and they're all 60. I can make it really big now. And it's still equilateral. They'd still all be 60. The angle doesn't change. The lengths can change, but on similar things, the angles don't change. So if D is 100, H is the similar angle, so H will be 100. That was easy. And guess what? We're on to 15. If I remember right, it's an octagon. 1, 2, 3, 4. Yep. Stop sign. How many lines of symmetry does this regular polygon have? Well, let's figure it out. I'm going to try to draw these as straight as I can. 1, 2, 3, whoops, 4. So there's 4. And can I draw it any, and what if I drew it like this? What if we went right through this point and this point? That would make perfect halves. That means I could go through that point and make perfect halves. So 1, 2, 3, 4, and then 5, 6, 7, 8. There's going to be 8 total. And I'll let you guys play around with that at home. But in between each corner, there'll be 1, and on each corner, there'll be 1. So 8. If you have any questions about that, give me a call. So which quadrilaterals always have lines of symmetry? Select all that apply. So a trapezoid, that's one that I would say does not. Boy, I don't know what happened there. I got ugly. Because I'm just going to draw it up here. Trapezoid. Boy, my computer just stopped. So that's just 2 parallel lines. And they can go any way. They could go like that. And so there's really no symmetry here because there's no way you could draw that. So trapezoid, no. Isosceles trapezoid, yeah. Because that means we're going to have some same angles. And so you could always draw down the center. So yes. Rectangle, yeah, 2 lines of symmetry for a rectangle, this way and this way. And a parallelogram. Let's think about this one. Now this means the top is parallel to the bottom and the sides are parallel. Can we draw a line of symmetry? I don't think we can. So if we fold it, well, yeah, maybe our line of symmetry, this would be like that, and then we fold it over and it would be perfect. So yeah, those are the 3 that always have a line symmetry. Okay. On to our last 2, 17 and 18, and if I can get them on the same screen, maybe my computer will quit giving me grief. Okay. Point A is located at 3 minus 8. Is translated left 5 units. What are the coordinates of the hyphen is the preimage. So we have point A. I'm just going to draw a little grid so I know where it is. 3, negative 8. And is translated left 5 units. So the preimage, the image, I always get confused with the hyphen. Left 5 units. So it's translated left 5 units. So 1, 2, 3, 4, 5. So that's negative 2. Negative 2, negative 8. Is that an answer choice? -2, -8. Yes. What are the coordinates of the image? So if the point A, the pre-image, is located at 3, -8, then what are the coordinates of the image? So point B is located at -3, 5 and is reflected over the y-axis. What are the coordinates of the image? So point B is -3, 5. And then we're going to fold it this way. We're going to fold along the y-axis. -3, 5. We'll say it's about there. So it's going to end up over here at 3, 5. That means that would be 3, 5. 3, 5. There we are. All right, we made it through this. Woo! I didn't think we were going to. We've had some computer glitches. Thanks for your patience.